Senhoras e senhores, bom dia. É com grande satisfação e alegria que nesta quarta-feira nos reunimos para o encerramento da terceira Conferência Internacional de Produtos Naturais e Saúde Humana.
Good morning, ladies and gentlemen. It's with great satisfaction and joy that on this Wednesday we get together for the last day of the third International Conference of Natural Products and Human Health.
Agradecemos novamente a presença de todos e convido a professora doutora Ana Paula Girol, chair desta sessão, para apresentar a última palestra do evento.
We thank again the presence of everyone and I invite Professor Dr. Ana Paula Girol, chair of this session.
Bom dia a todos, bem-vindos. I'd like to introduce now Professor Artur Silva. He's our keynote for the last lecture. Professor Artur Silva has a degree in chemistry physics, a PhD degree in organic chemistry, habilitation on chemistry, and is full professor of chemistry at the Department of Chemistry, University of Aveiro. His curriculum is huge, but he's asked me to short it a little bit, so now I'm going to present his line of research. Artur Silva's research interests range over the chemistry of polyphenolic and nitrogen heterocyclic compounds, with special emphasis on the development of new sustainable synthetic routes, and also on the organocatalytic and metal-catalyzed transformations. The second passion of his research is centered in the isolation and structural characterization of natural products from diverse terrestrial and marine sources. Also, his research focuses on the synthesis of biologically active oxygen and nitrogen heterocyclic compounds, as well as on the evaluation of their antioxidant, anti-inflammatory, anti-tumor, and antimicrobial activities in collaborations with other Portuguese and international research groups. Please welcome Professor Artur Silva.
Good morning, bom dia. It's a pleasure to be here. So I would like to thank Ana Paula for the invitation to allow me to come to Catanduva and once again to Brazil, and thank for this very good atmosphere that are among all the participants in this meeting. So now I will try to do a presentation, not a chemistry presentation, because the audience are far from this. So I tried to put here a collection of our data about the plants from different countries, not only from Portugal, but also from East Timor and from Argelia, from let's say Africa. And we try to look at some underexplored or underexploited plants and try to see the applications in terms of medicine and also the food. And I will try to do this in a little bit far from chemistry, but in some cases to put some chemistry in some pictures about chemistry. So the main goals of the presentation, it will be these three. So the valorization of unexploited species and try to confirm some of the medicinal and nutritional value of these plants, because some of them are used in folk medicine and as food supplements, and also to understand a little bit of how the climate changes can impact on the metabolomic of profile of some plants and In one case, it's from a specific plant from Portugal, but it's all over the world like this. So, and of course that we will need to use some chemistry tools, and we will use GC and UPLC to do the characterization of these compounds, of these plants. But also in some cases we isolate the compounds to have this as a pure compound and then to look at them as a secondary metabolite. So the background of the presentation, I can say it's the medicinal use of plants is growing globally. As we have seen yesterday, I have seen only a small presentation, and natural products are gathered, increasing attention for. But we must be careful because natural do not seem that are safe. And whereas we know that some compounds are natural but are very toxic. So we need to validate. So it's the validation of these benefits is necessary to do it and we improve the safe of some of these compounds. Another point that we are witness is the increase of saline water and the decrease or the scarce of fresh water. And we can say that estimated by 2050 that 50% of the arable land will be salinized. So we think that soil salinity is considered one of the big threats for security food or for food security and sustainable wild world. But of course that most of the crop species in modern agriculture can only survive under limit sodium chloride concentration. And I will show some of the plants that lives in these systems. Of course that all these three facts can stimulate or are stimulating development of saline agriculture. One of the first example that I will show, it's about halophytes from the Rio de Aveiro, and then we have, it's a salt pan, and it's an exceptional growing for these halophytes, and we will show some of them. Several are unexploited, but can be, or that are exploited at the moment and can become in near future important substitutes for conventional crops. One of those is Saliconia ramosissima, that can, it's nowadays in Portugal, in the old wild, it's because its cultivation is spreading and it's already used in the gourmet food as replacement of salt or sodium chloride. Is appreciated in different parts of the world, and we have also established the nutritional value of this plant because we isolated some of the secondary metabolites and we evaluated the biological activity of this plant. And we can see that we we have done the hexane extract. We we determine the composition of this hexane, and we identified, as it is written, 50 compounds from this. We have identified the most abundant ones, that is written there, but the most important one is this one. The second sentence is 90% of the fatty acids are unsaturated fatty acids, and 5% is polyunsaturated fatty acids, being 1.6 is the cis fatty acid. This to the PUFAs and the CSF is important in terms of the biological activities of these compounds. And another point that we have determined is the ratio, the omega-3, omega-6, omega-3, and is very far from 5. So it's suggesting the high nutritional values for this hexane extract from the Saliconia ramosissima, and is considered healthy from several organizations. But trying to look a little bit for the cultivation of this plant, we have done this for experiments. One is natural irrigation from the plant. Another one is with additional irrigation. It means each 15 days we added some water, but because we are trying to change the environment that in which this plant is growing. And of course, then we have done some chemistry because we are trying to see if how it is the compounds in the plant. It's why we do with hydrolysis in both cases. And what we can say is the profile is more or less the same, being irrigated or not irrigated. And the major compounds, as it is written there, is fatty acids and long chain alcohols and sterols. Of course, that then we look to the sterols that can, and this you know better than me, this is important for LDL cholesterol lowering effects. And the other two parts is about chemistry. All the compounds are more or less in the free form, save 4 of them that are in the esterified form. It's why we have done this with alkaline hydrolysis, try to look at this composition and try to understand a little bit about the metabolome of the plant. What we can say is irrigated or not irrigated, we obtain the same profile for the plant. It was interesting because we found a new compound. This is, for those that work in natural products, it seems a strange compound because it's a dimer of the T-butylphenol. It's that structure, the T-butylphenol, it's a dimer, and have this bridge between them. And we identified all the parts of this compound by NMR, but then because we have a symmetric structure, half is identical to the other half, we needed the mass spectra to determine the structure. But it was interesting because it's the first time that we isolate this type of compounds from this plant. And of course that some of the features of this plant is important for the biological activity, like the platelet activation factor in the human body. So, but we would like to look another unexploited plants like Calendula officinalis. It's easy in traditional medicine to treat some of these infections since the 12th century. And the infusions is suggested to have some nutritional value. But it's about, and what about the other species of this calendula? This is one of those that we studied, but this another ones. Because in Portugal, in mainland of Portugal, we have different calendula, and we studied 3. The Calendula arvensis and then the Sufruticosa, 2 subspecies. And as you can look, it's important here, as you can look to the profile of the metabolome, is quite different. Because if we look at these 2 different species, subspecies, the composition is completely different. And if we look to this one, to the Algarviensis, we can see that the major compounds is hydroxybenzoic acids and is pyroxylidine alkaloid. So it's this big let's say, part of the compounds, and this one here. So, but in the case of, we look at these ones, there is this big difference between the composition. But what we can say is that we can use the profile of these plants to identify the compounds that we are interested in, but also in terms of the applications, it can be completely different because the composition are different from each other. And of course, some of the presence of some of these compounds, like in this case, is responsible for the medicinal and nutritional value that we have found. But as I referred in the beginning, we are not only interested in Portugal, but we look at the other plants from the other continents. And we looked at Artemisia herbalba from Algeria. And once again, it's used in traditional medicine. And in this case, we look at the essential oil. And as you can see here, we identify almost all the compounds that are there because we identified 99% of the composition from this oil. And we identified that almost 50% or 51% is camphor. And we determined immediately the antibacterial activity And we found that here we can have good antibacterial agents because the activity that we obtained, it was higher, and toxicologically the oil seems to have a safe level because in terms of the medium lethal dose, it was very safe in terms of what we have obtained. So this essential oil that we obtained from this Artemisia can be a source of the antibacterial agents. Another example is this one, Scalabiosa stellata. It grows in these conditions, in dry sunny grassland and rocky hillsides. And here we identified a lot of polyphenolic compounds, and mainly one flavone, is orientin and is caffeoylquinic acid, the major compounds. Of course, that then we looked not only to the extract, but we looked to the phytochemical composition. We isolated the compounds, and we identified quite a lot flavone glycosides. And the one of those is derivatives from tamaraxine derivatives, and here we show the main structure. And this, the activity of this compound, it's very interesting. Of course, that the nutritional value of this plant can be, that we have obtained, allow to incentivize the consumption from the people from there. After this background, I will look to 3 different cases. Of course, that in each one, I will present a lot of examples. For example, if we look to these 4 plants, of course, from Rio de Aveiro, where we found it, all of them, and we try to establish the profile of this compound, of these plants, these alophytes. And we can divide in these 3 main compounds: flavonoids, cinnamic acids, and other compounds. And as you see, the big amount is flavonoids. But then we look deeply in each one of these compounds, in each one of these family of compounds. And as you can see here, when you look to the cinnamic acids, we identified different. The composition are different. If we look, of course, that the acyl monosaccharides is the major important compounds from this group of this family of compounds. And chlorogenic acid is also important in terms of application. But if we look to the, if we look to the flavonoids, here we have a different. This we show 2 structures to show you a little bit what is written there in terms of trypsin glycosides are here from this part, and the epigenin is from this part. So if we look once again, there is different profiles. And for example, in terms of flavonoids, one of those almost have nothing, and the other has also a very important. But if the major important ones is the trypsin and epigenin derivatives, this type of compounds. Of course, that for those that are not chemists, it's a structure, but it's important only to show this. In this case, we have a sugar connected to our compound, but it's from this carbon-carbon bond, so this compound resists to our stomach, so there is no cleavage of this sugar. While in this case, we have here an oxygen between the connection between the sugar and the structure of the flavonoid. So in the stomach, we can cleavage this bond here. So the difference between these compounds is this. This compound is called C-glycolyl flavonoids, and it is very important because it resists to our stomach. Well, but if you start with same families, so in this case Spartina and Puccinelia maritima, both, and we look to the composition, and you see here what we seen. This is once again the hexane extract, as it is written there, and the major compounds are the terpenoids. Of course, that we look a little bit carefully. We have the terpenes, the terpenoids, and steroids. So this is the one we put this in bars Of course, that we lose a little information, but it's rare this because sterols is the major important part of these terpenoids. And it is possible to conclude that this extract can be relevant to be used as nutraceutical due to the composition in terms of sterols and terpenoids. Of course, that then the chemist look to this composition, wants to isolate all the compounds. We isolate all of these compounds. And what we have obtained is, or we have seen, is that the amount of each one of these terpenoids is maintained, although we change the level of salt in the crop, safe in these compounds. This one, the campsterol, in the case of Sapartina maritima, it's increased with the salinity when we increase the salinity of the soil where we were growing the plants. But this is important. It was to look at the composition, to isolate the compounds, and then to do a little bit of the evaluation of the activity of these compounds. When we do the principal component analysis, we have obtained the composition in terms of the compounds. But with this experiment, we try to see which is the families or which is the biological pathways that are responsible or are responsible for these plants to be tolerant to the salt environment. And with this, we have obtained that for the Puccinia maritima, we have 6 compounds that are responsible for this, let's say, resistance or tolerance to the salty environment. And in the case of Spartina, it's 8 compounds. Of course, it is a way to look, and it's important is from the yellow to red, and which the significant impact is when we have the red spots. And we can look here the biological pathways that were involved in this compound that we isolate here. And the important aspect is when we look at this, is that we can see when we see the overproduction of some compounds because of the plant are in salty environment, and if we increase the salt environment, there is the overproduction of some compounds, and so here we can see let's say the link between the overproduction of these compounds and the pathways that we have in the cell. So now I will try to choose the different plants and try to look at these plants not as a whole, but with considering different parts. In this case, we looked at the flowers, 2 types of flowers, and you can see here, the flowers 1 is young flowers, and the flowers 2 is fully germinated flowers, and the 3 part is leaves. And if we look to the composition of this hexane extract, that it's written there, the chemical composition of the young flowers and the leaves are more or less the same, follow the same pattern, and the fully germinated flowers have different composition. We can see the profile in each one of this family of compounds that we see the same profile. But we were trying to look at one specific compound. When we looked at the beta-citosterol, it was the same. So the flowers and the young flowers and leaves are more or less the same, and then the fully germinated is completely different, the composition. But then when we are looking at this metabolome profile, we look also to different compositions, to other parts of the composition. In this case, we have the ethanol extract, the more polar compounds. And we can see once again here that you see the 3 parts is flavonoid, caffeoylquinic acids, and hydroxybenzoic acid. So, but if you look at the 3 parts of the plant, we follow more or less the same. we have the profile is more or less the same, although in case of the flowers, we have a bigger amount of the flavonoids. We look here in terms of the structure. I will not show you in detail, but it's particularly rich in flavonoids, but from which the myristin derivatives are the major ones, are the most important ones in terms of the composition. So if we look at another plant now, it's once again used in medicinal. It's a medicinal plant used in traditional healers and in India and also in Algeria, because it's the country, the most close country that we are looking to the plant. So here we look at the seeds and the yellow parts, and we can see immediately the difference between them. If you see here, in terms of the seeds, the major compounds are carboxylic acids and flavonoids. But if you look to the yellow parts, it's saponins. Saponins is a bigger amount of the composition of this So here we can show a little bit in terms of, once again, we determined all the structure that was behind of these cheeses, but here we show a little bit the compounds, the major compound that we isolated in the methanol extract from these parts. Of course, that when we want to look at the nutritional value, we look also to the health-promoting ions, and here we can find sodium, calcium, magnesium, and iron, and this can be highlighted in terms of the nutritional value of the plants. Looking to the calendula once again, but here trying to use calendula from Portugal, from the same geographic region, but with different environments in different parts of Portugal. And for example, if we look to the 1, 2, and 3, it were cultivated in more wet conditions. And then if we look to the profile of this metabolome, we can see that these 3 that has the more wet conditions is completely different from the others. So when we look to an extract that to be used as a food supplement or as a medicine, we need to consider this part. Of course, that for me as a chemist, we wanted this to isolate the compound, to have the pure active principle. But when we look to the extract, these are similar, but these are not similar. So although they were cultivated in Portugal, and Portugal is very small, but depending on the conditions of the cultivation, we have different profiles in terms of the composition of the extract. Here we show as the one in the same type of the calendula, and now we look to the terpenoid profile. And you can see this in the specific family, the profile is completely different, because here we have almost in terms of the triterpenes, this species has a bigger amount, and this cases has almost negligible amount of this. So we can use, in this case, the terpenoid profile can contribute to a genetic differentiation between the species and the species that were cultivated and isolated these extracts in Portugal. Well, now we look to the plant that is used in our region, and it's called Genista tridentata. It's a medicinal, with a medicinal significance. It's a shrub, not a plant, it's a shrub in the Iberic Peninsula, but near Aveiro, in medicinal folk, it's used to treat several health problems such as diarrhea and hypertension and so. And when we started this study, there was a little information about this plant. And what we have decided is to use different parts of the plant, so roots, stems, and leaves, and we perform the ethanol extract. And if we look for those that, for chemists, we look the composition of these are flavonoids and isoflavones that are not typical in this in the plants. And the amount of isoflavones is bigger in all the parts. Of course, that in the leaves there are less, but in terms of roots and stems, it's almost only isoflavones that can give us some information about this, the biological activity that we have found. In this specific extract, we isolated several compounds and we determined a new compound. We isolate a new compound. This is a new compound isolated from this plant, from this region. Of course, that once again we establish all the structure by using NMR, and even because here there is a specific arrangement of this substituent, we establish it through the NMR to see how it is the arrangement. Of course, this compound has this part. This is prenyl derivatives of the natural compounds, and this a specific family that has important biological activities and are responsible for the biological activity that is known for the compounds from our region. Of course, that then we look at all the composition in terms of isoflavones and flavonoids, and we can see the structure that we have obtained, that we have identified in terms of sugar, that we have the isoflavones and sugar connected to, and the other parts of the isoflavones, and the same as for the flavones. It's a very, very interesting study, and at the end, we have shown this. It's the extract has a strong antioxidant, anti-inflammatory activity at cellular level due to the presence of these compounds, and we are now looking at the activity of each one of the pure compounds. Well, now looking in the different area is also Argelia, but it's now near the Sahara. It's the extreme conditions that where this plant is used. And we isolated, we have done an extract, and then we evaluate the biological activity in terms of the antioxidant and anti-inflammatory. And in this case, we have used 2 animal models, as it is written there, and we looked also to anti-nociceptive properties. And we have different ways to evaluate them. And the result that we obtained supports the traditional use of this plant. Sorry. And this is, it was, we know already the structure, the composition of this extract, and then we looked immediately to the activity in terms of the animal models. And this is one of the major compounds that we obtained. And once again, it is the structure of the flavonoid. And now we have 2 residues of the sugars. It's not only 1 sugar, but it's 2 sugars and with different compositions. Another plant that is, for example, is typical from Aveiro, from Brazil, because I studied is endemic of our beach. The Artemisia campestris, but in Brazil there was a collaboration that I have also to study the structure of these compounds. Of course, that when we look to the profile of the chromatogram, well, we have a lot of peaks, but then we look at the composition and we studied all the compounds that we have. And in this case, we try to have a methanol extract, and then we collected only a part of this methanol extract for trying to have an extract rich in flavonoids, and then to look at antioxidant activity, and it was important. And this extract shown an important biological activity in terms of anti-inflammatory and antioxidant activity, and now we are trying to look at the isolation of some of these compounds because some of them has very interesting structures for the biological activity. If we look to another part of the world, for East Timor, and this plant is used in the kitchen. It's used for traditional medicine, but also it's used in the kitchen. But the major part is used to treat infections. Of course, that we have here the chromatogram of the two parts of the plant is the rhizomes and the leaves. And of course, that when we look immediately, we have seen this here, don't have almost nothing there, and so different parts, different compositions, and the total amount of these compounds, if we look here, we can see that are completely different. If we look to the leaves, what we have, the major compounds are, these are here, the blue is the carboxylic acids, and in the case of rhizome, we look immediately because the most important ones are alkaloids. So when we look to different parts, we can think to have different applications because we have different compositions for these parts. Of course, that the leaves, this part here, some cases, the leaves are rich in PUFA, polyunsaturated fatty acids, and this justify a little bit in terms of the nutritional value of this part, and also that the rhizomes is rich in triterpenoids, in special in this derivative cycloartan, because it's involved in biosins of phytosterols, and it's also incentivized to the production of milk by young moms, and it's why they use in the traditional medicine for the young moms. So, but then we look to the composition of the triterpenoids. If they're important in terms of the production of milk, so we try to look to the composition of this, and this is the major compound that we have isolated. It's a family complicated in terms of structure, in terms of, because as you'll see here, it's beautiful to write these pictures with all this chemical structure, but the determination of the structure is not easy. And it was a long work by NMR and mass spectra. Another one, North Africa, treats inflammatory diseases. And we have obtained interesting antioxidant and anti-inflammatory. And namely for the presence of these two compounds. Taxifulin is this flavonone. It's here with this arrangement of the substituents, is this specific one, and also the 1,3-decaffeoylquinic acid, this structure. So it's these two main compounds from this extract that are responsible for the interesting biological activity. And then what we have done, we isolate each one of these compounds and we determined the structure and confirm a little bit what we obtained in terms of extract. But when this extract show important alpha-glucosidase inhibition, what we have done some docking interaction between the two major components that we have shown in the structure before, and also the alpha-glucosidase, and it's confirmed because the bonding of our molecule with alpha-glucosidase in the pockets of the glucosidase is quite well, it fits quite well. So the docking interaction justify the biological activity that we have obtained for this extract or for these two plants. So I look at another plant as from Algeria, and this also once again we have good information from the medicinal potential of this plant in terms of the anti-hyperglycemic activity. And we try to look and to try to understand, and the major compounds that we obtained in the aqueous extract and the ethanol extract are flavonoids. And at this moment, we are trying to isolate the major compounds. In this case, it's more difficult because there is a lot of compounds with the same amount. But we are trying to look at this and try to correlate the structure of the compound that we identified in these chromatograms and the activity that is shown by this extract. Of course, that we see that is rich, all of the both extracts are rich in caffeoylquinic acid, and in being the 5-O-caffeoylquinic acid, the most important one is that one that it's there. So we tried also to correlate the presence of this compound with the activity that is shown by the extract. But it was interesting because from the ethanol extract we found a new compound. It's for the chemist is a different structure because normally these rings are connected directly to that one. And here we have an extra carbon, and we are looking to see if this compound with a bizarre structure, if they have some let's say, or if he is responsible for the activity that is shown by this extract. Another plant is Inula viscosa, and this how we start. We start our colleagues from Arzelia try to and look to the inhibition of the growth human gastric and lung cancer cells, and we obtained immediately good activity. So we tried to find the profile of the compounds that are there, and once again we have caffeoylquinic acids and flavonoids, and of course we know that these two compounds are responsible for the anti-cancer activity. And from the caffeoylquinic acid, there is one specific one that is the most important one, that is 1,5, and in terms of flavonoids, idmyristin and quercetin methyl derivative. So immediately we looked for the anti-cancer activity, and then we looked to the structures, and this is the major structure that we have in the extract. Of course, here's the biological evaluation that we looked at the inhibition of the growth of the human, the gastric and the cancer cells, and we can see good interaction, good activity, and also we highlighted that the ethanol extract, the selectivity, because we compared with non-cancer cells and to look a little bit at the selectivity of the extract, and it show also that it's have a good selectivity. The last one, it's a little bit about the climate change. And looking to Olea europaea, that it's very important for the economy of Portugal in terms of production of oil and also the table olives. And although it's the olive leaves have also been utilized in traditional medicines, but the most important ones is the production of olive oil and table olives. So it's important for us and for the economy. Of course, that there is the climate change that we can see from the temperature that we have here and we have in Portugal at the moment. We must have cold and we have 30 degrees in Portugal. So we need to see how we can protect this plant. And we have used some extreme conditions in terms of heat waves, high UV indices and drought periods. And this is the conditions that we have faced during the last years, and I think that will be in the future. So we have three groups of plants. We have the control one, well irrigated. We have another group that was not irrigated at all by 30 days. And the third group is not irrigated for 30 days. And in the days 28, 29, it was heated and submitted to the UVB shock simultaneously. So we have tried to look at these three different, these three groups of plants. Of course, that then we looked at different composition. I will show only two results. And of course, in the first part, we have after the stress exposure, we determined, we have done the extract to determine the composition of the extract. And then after stress recovery, what happens to the plants? And as you can look to the left-hand side, we can see that the flavonoids is the compound that are involved in the stress conditions and in the recovery after to be submitted to the stress condition. The plant produces a lot of flavonoids. In this case, it was luteolin acetylglycoside. And in the right-hand side, in terms of, let's say, oleuropein, and you can see also, it's involved in stress exposure and also in after the recovery, there is a production of this oleuropein in bigger amount. So it was only to show a little bit that we can study the climate changes and to see with a specific crop that was very important for us, for Portugal. And well, after this long journey that I have to do through different plants, I can say that we have shown the chemical richness of several plants from Portugal, Algeria, and Timor. In some cases, we established and we shown the nutritional value. The biological evaluation proved and confirmed the major part of the medicinal value that is known for the plants. We isolate some of the compounds to have it as a pure compounds, but we still look at in some cases, because we want to have the active principle, not only the extract, because the extract can be different from the geographical, when we look to the geographical diversity, but also when the conditions, how it is, the crop, the plant is produced. Of course, that during this journey, we identified 2 new compounds, and mainly this one proved to have very, very interesting applications. And of course, that the impact of the extreme weather conditions, it was evaluated for the Europeia, or for the Portuguese, for Oliveiras. But we use these tools, the GCMS and the UHPLCMS, but also the NMR and the mass spectra when we isolated the compounds. Of course, that all the impact of the growing environment that I show for the calendula, because the calendula, even being cultivated in Portugal, if we have different conditions of production, the extract, the composition that we have is completely different. So all the analysis we can, we try to contribute to valorization of several natural resources that it were unexploited before. I would like to thank all the authors involved in this work, and a lot of PhD students, master students, and researchers. Also to those that give us some money, the university, and also the project that we have, our research center. For those that do not know Aveiro and the University of Aveiro, this is our campus, this is our library. It was built by a famous architect, César Vieira. This is the major part of the main part of the central part of the campus. This is the rectorate building, where my office is over there or something like this. And this is a little bit about the city. We have our boats, the typical boats. In the past it was to collect, it was used to collect algae, but nowadays it's to collect tourists and to put the tourists along our lagoon. This is typical houses from near the beach, where we have typical houses from the fishermen. And this is an overview of the city, where we have a lot of canals, a lot of water around. And I would like to thank you for your attention.
Thank you very much for your brilliant talk and for sharing with us all these interesting results. We've got time for questions, if you want. Yeah?
Thank you, Professor Artur. My name is Marco. I'd like to make just 2 questions. What are the concerns for the future when it comes to the massive production of these plant products? And another one, what could be the impact of this massive production on the environment?
Do you mean the production of the plant or the compounds that we isolate from the plants?
For the compounds. Yeah.
So what we try to look is this, if we look at a plant, we can try to look at the extract, is the first. The plant is there, we eat the plant, like we have the vegetables in our kitchen and our food, for example, we can say in the Mediterranean, we have a lot of olive oil, we have a lot of greens and so, and we eat the compounds. It's not necessary to do an extract. What we try to do at least is, if we obtain an extract that can be more rich, that we can take it, of course. It's why I stated at the beginning that we need to look at the safe of this extract, because it's our chemicals. Of course, it's like a drug, depends on the dose that we take, and it's necessary to do it. But then we look at this. But then, in some cases, as we know, if we want to have, for example, a good anti-cancer activity compound that presents important, it's why we try to look at the composition and to try to isolate some of the compounds, because in the pure amount, if you have because normally it's like a perfume. If you have a perfume, it's, well, you have a composition that it's impossible to have another one. But for specific application in terms of the anti-cancer or anti-inflammatory, we want to look at the specific compound. So we are trying to look at the extract and try to have the principal active. So but the origin is plants that we eat, that we use in the traditional medicine as a tea or as something like this. But then we look deeply to try to isolate compounds that present higher and very specific activity.
Thank you.
Mais perguntas? Ninguém tem mais perguntas?
Hi, Prof. I enjoyed your presentation. The fact that, as you started the presentation, you said climatic change has an impact on the natural plants. In your research, what do you, in your expert interpretation, will climate change have an impact on our natural plants in 5 years down the road? That is the question.
Well, the climate change is completely different from one part of the world to the other. So, and when we try to look at this, it's like we have done for the Olea europaea, because it's important for us, and we try to look to the stress that these plants are facing. And normally we have olive oil, olives, Olea europaea in the north, in Trás-os-Montes, and in the south. And where the temperature are, that is the interval, it's bigger, very big. And we are facing some extreme conditions in terms of temperature. And it was temperature and missing some water. And it was, we look at these two extreme conditions. And of course that nowadays to the ozone hole, we have also UV light that comes strongly than before. And so in this, the third aspect. But it was for us, for this specific plant. In different parts of the world, perhaps we need to look at the other different aspects of the climate changes, because during this summer, Slovenia has a lot of floods. 70% of the country stay underwater, and it's not normal. So perhaps for this part of the world, we need to look at the excess of the water and not the scarcity of the water. So when we look to climate change, I think we must look at for the specific plant, for the specific part of the world, and the extreme condition that we will have there. So for this specific plant, it was these three conditions because it's the ones that we are facing nowadays.
More questions? Okay. Professor Artur é português, fala português. Quem também quiser fazer perguntas em português, fique à vontade, ok?
Sem problema.
Sem problemas, né, professor?
Good morning, Professor. My question is, here in our country, for example, we have kind of a prejudice against natural products to treat diseases. So what I would like to know if in Portugal or Europe in general, nowadays you can isolate the compounds who brings benefits, not only the plant extract, if the pharmaceutical industry has more interest on financing and developing new pharmaceuticals to treat chronic diseases and even cancer.
Well, this is a long discussion, not only in Brazil, but in Europe and in all the countries. Today, I show you only natural products. That's okay? But in my group, we are a synthetic group. So I have two parts of my group that look at these structures, beautiful structure that we show. Because when we look at a plant, imagine that you found an important anti-cancer activity for one specific compound. But if you look at this from the plant, we can have some milligrams, or in some cases some micrograms. But we need to have tons if we want to apply this for the medicine. So we need to synthesize the compounds. So I think that there is different discussion. So the first is about the extract. If we have an extract from Aveiro, and from Lisbon and from Alentejo, is completely different the composition. So we need to look at this because we cannot treat the same person with these three extracts because the composition is different. It's why I show the calendula in all Portugal in different parts and with different cultivation aspects, and the composition is completely different. It's why normally then we try to tune the extract and to try to collect part of the extract that has the active principle. But once again, what we want as a chemist and then the pharmaceutical companies want that we show from this extract which is the active principle. If this active principle is very important. And then we look to the synthesis. I can tell you that I had a patent. And at the beginning, it was the application in terms of anti-cancer, it was excellent. That's okay? And we prepare the compounds. We prepare several grams of compounds, not because when we start it's 5 milligrams, then 10 milligrams, but then the company asked me 3 grams, then they asked me 100 grams. But then when we are at these 100 grams, we have the problem. Because the method to synthesize the compound, it's too long for the company. And the company said, no, it's not important. After all this journey that we have the patent, we have the company that were interested in the compound, but the method to synthesize, there is a lot of steps to do it. And then it was abandoned. So normally we start by the nature to see where it is the compound. If there is a good compound, then we try to look if we can synthesize. Then we see the patent, then we look to the pharma company, but at the end, in our case, it was after 5 years, we put it in the aside because it's not important for the company. For us, it's important, and for the student, it was important. It has a patent, and so with important application. But finally, we don't have this compound in the market because it's too long to synthesize the compound. So the difference is, once again, we look to the extracts. We must be careful about the extracts because the composition can be different from, well, 100 kilometers from the other side, it's completely different. We try to look at the specific composition. We try to see the principal active and then to synthesize and all the process.
Thank you.
More questions? Okay.
Thank you, Professor. It was incredible.